So there's a subtle difference between the two of them because it's 9 times the number here, it's just 9x. Since it's 9 times the difference, it's 9 times parentheses around the x minus 7. So when it's 9 times the difference, it's implying you get the difference first, or you subtract first. Now, as we mentioned, the word is implies an equal sign. So if I were to tell you that 3 times a number decreased by 2 is 23. Now that implies an equal sign. Is 23 implies that something equals 23. What equals 23? 3x minus 2. Very good. And now I could solve that equation. I would add 2, you get 3x equals 25, and divide by 3, get x equals 8 1/3. See how simple that is? Now that's relatively simple. That's just straightforward, flat out giving you the equation in words, and you just have to write it out. We can get a little more complex than that. We can say something like the sum of 2 consecutive integers or whole numbers or whatever. What does integers mean? It just means it has no decimal or fraction. It can be positive or negative, but no decimal or fraction. Is 43. So I know that something equals 43. The question is what? Well, there's 2 integers, right? I suppose I could say x plus y, but I don't know how to solve an equation that has 2 variables in it, do I? I need to get it down to just one variable. So what I have to ask myself, is there any way that I can make one of them refer to the other one somehow? So I have 2 consecutive integers. This means there's one that's going to be the smaller one and one that's going to be the larger one, right? What's the relationship between them? Well, the larger one is how much bigger than the smaller one? 1. So if the smaller one's x, I can let the larger one be x plus 1. I've referenced it off the other one. So now x plus 1, x plus x is 2x plus 1 equals 43. And now I can solve. I can subtract 1. 2x is 42, or equals 42, and I can divide by 2. X equals 21. Now, I'm not done. Now, I didn't write it down, but I'd asked, what are the 2 numbers? Well, x is 21. That's the smaller one. The larger one is x plus 1, or 22. So the 2 numbers are 21 and 22. Let's look at a slightly more difficult version, or slightly more applicable version, rather than just a number sentence like that. Like this. Let's say that Pete is 7 years older than Sam. The sum of their ages is 41. Find their ages. So we might have P plus S equals 41, right? But again, we don't want 2 variables. That's P for Pete's age, S for Sam's age. Can we reference one of them off the other? Well, Pete is 7 years older than Sam. So what does that mean? That means that P is S plus 7. Sam plus 7. Does that make sense? So Sam plus 7 is Pete, plus Sam equals 41. So now we have S and S make 2S plus 7 equals 41. And then we solve. So we subtract 7. 2S equals 34. And we divide by 2. S equals 17. And then, of course, Sam is 17. That's S. Pete is 17 plus 7, or 24. Make sense? That's it? Makes sense. Well, I do understand that doing it here, it seems so simple, because doing it is the easy part. It's figuring out what to do. And here I'm giving you little pushes in the right direction of what to do. The calculations are easy. It's figuring out what to do next, what calculation to do. That's the hard part. Let's look at another one. The perimeter of a rectangle is 5 more. Sorry, the perimeter. The length, I should say, not perimeter. Sorry about that. The length of a rectangle is 5 more than its width. The perimeter is 130. Find the length and width. Give that one a shot in your notes. See if you can make. So, let's draw a picture here. We have a rectangle, there's the length and there's the width. And the perimeter of a rectangle, of course, is just length plus width plus length plus width. Or I could simplify that. The perimeter is 2 times the length plus 2 times the width. But again, I still have 2 variables. I can replace the perimeter P with 130, but still 2 variables. We know that the length is 5 more than the width, so the width plus 5. So now in this formula here, length is W plus 5 instead of just L. So replace the L with W plus 5, plus 2W. Now we can solve it. The 130 doesn't change. 2 times W is 2W. 2 times 5 is 10. And 2W. So yeah, 2W and 2W is 4W. Still plus the 10. And now we just solve the equation. Any questions on how we got any of this? Any questions on where this came from? So subtract 10. 120 equals 4W. And divide by 4. 30 equals W. Well, that's just part of the problem. We found the width. Bless you. So the length is 30 plus 5, so that's 35 is the length. So now we've answered the question. 30 by 35 is the rectangle. That one's, again, it's a little bit more complex, but there's not a terribly practical application to it. But let's look at something that might be a little bit more practical. Let's say you have a business, and in your business, you have 2 products that you're going to sell. And based on your experience, you believe that product A will sell 3 times as many as product B. Product A sells for $5 and B sells for $12. Yeah, we'll go $12 each. You need at least, oh, what do I want to do here? $270 a week in sales to cover cost. How many of each do you need to sell to meet your minimum? So I've got product A and product B. One of the things I need to express is the number sold. Again, I could call that A and B, but that doesn't help much. So what I can do is this. If I let B be X, why would I let B be X instead of A? Because A sells 3 times as many as B. If I let the number of product B sold be X, that makes A 3 times X. Does that make sense? One of the amounts has to reference the other. The number of A sold is 3 times the number of B sold, so 3 times X. Next, I need the amount of money from each. Now, if you have a product that you're selling for $4 and you sell 3 of them, how much do you get? $4 each, and you sell 3, you're going to get how many dollars? 12. How'd you get that? 4 times 3, yeah. The number sold, the dollar amount times the number sold. Well, the same thing here. A sells for $5 times, if we're going to sell 3x of them, that's 5 times 3x, or 15x is the amount of money we're going to get from product A. Product B is $12 each times X sold. 12X is the amount of money from product B. Does that make sense? And we need a total amount of $270. So 15X plus 12X has to be 270. $15X and 12X make 27X equals 270. So that gives us, after we divide by 27, X equals 10. So X equals 10, that means there's 10 of product B sold. A is 3 times X, or 3 times 10 is 30 of product A sold. Make sense? Okay. Our next application is a little bit more complex. We're going to talk about mixtures or solutions. In a mixture, for you guys in automotive, one of your main mixtures would be antifreeze as a mixture. That's actually a solution. It stays dissolved. But it's a form of a mixture. In a mixture, there's 2 substances. There's the carrier. If it was a solution, it would be called the solvent. And then there's the substance, the solute in a solution. For example, we're looking at salt water solution. Salt would be the solute, and the water would be the solvent. The water is the carrier, the main substance that's held there. The amount of substance in a solution is equal to the concentration, or the percent, times the volume of the solution. So for example, if we have 300 milliliters of 12% solution, that means that there are 12% is 0.12 as a decimal, times 300 milliliters is 36 milliliters of substance in that solution. Does that make sense? So let's say that you have an antifreeze solution. This would work on the farm for like an acid rinse solution as well if you're diluting it down. Let's say you have 200 milliliters of 24% solution and 300 milliliters of 42% solution. If you mix those two together, what percent will the final solution be? Well, you have 24% that you're mixing with 42%, and you're going to get some unknown percent. But the amount of substance before you mix it has to equal the amount of substance after you mix it. So we'll start out in the 24% solution. It's 0.24 times the volume of 200 milliliters. And I put the volume in parentheses just because that's the way I'm used to seeing it. This 0.24 times 200. Plus the 42% solution is 0.42 times, how much of that do we have? 300. Equals, I don't know the percent of the concentration of the final result, but I do know how much there is because I have 200 milliliters plus 300 milliliters makes, better be 500 milliliters, right? So now 0.24 times 200 is 48 milliliters. 0.42 times 300 is 126 milliliters. That equals x times 500. And now we're going to solve for x. 48 plus 126 is 174. Equals x times 500. What are we going to do? Divide by 500. 174 divided by 500 is 0.348 equals x. So it's 34.8% is the concentration. What do you think? Not so bad? You don't like it? It's going to get worse, don't worry. Any notes? Find the concentration if you mix 350 milliliters of 40% with 650 milliliters of 60%. Try that in your notes quick. So we have 40%, 0.4 or 0.40 times 350, plus 60% is 0.6 or 0.60 times 650, equals x times, how much do we have total? 1,000, 350 times 650. So this will be, what, 140 plus 390 equals, I'm just going to write this as 1,000x. X times 1,000 is 1,000 times x. So 530 equals 1,000x. And we divide by 1,000. So 0.53 equals x, or 53% is the final mixture. That's not terrible, right? But it does get worse. Let's say now that you have 11% and 26% mixtures. You need 16% mixture. So here's my question. How much 26% do you need to mix with 120 milliliters of, not 26%, yeah, oh, sorry, yeah. How much 26% do you need to mix with 120 milliliters of the 11% to get to the 16%? So we have 11%, and we're going to combine it with the 26%, trying to get to 16%. Do we know the amounts of either of those? We have 120 milliliters. What does that go with? The 11%, right? So 120 milliliters goes with that. So let's try to write our formula. 11% is 0.11 times 120 milliliters. Plus 26% is 0.26. Do we know its amount? No, so we're going to call that x. And this is going to equal, we want this to become 16%. That's 0.16. Do we know its amount? Sort of, right? How did we get the 1,000 right here? Well, 350 plus 650, right? That amount always has to be these two amounts added together. Well, down here, our amounts are 120 and x. So it's 120 plus x, or x plus 120. Does everybody see where the x plus 120 comes from? We're just adding together those two volumes.
Why is it not 120x?
It's 120 plus x. Yeah, not times, but plus, because we're adding them together.
Oh,
yeah. 120x would be 120 times x. Right. So 0.11 times 120 is 13.2. And this is 0.26x equals, so we've got to multiply through the parentheses, 0.16x, then 0.16 times 120 is, what, 19.2? And now we have to solve. We have an x on each side, so I'm going to get rid of the smaller one. I'm going to subtract 0.16x. So now I have 13.2 plus, this is 0.1x equals 19.2.
Okay, the one that gets me is like, when they're on the same side, you say have 2x plus 3x equals 3x. On the left side, you just have to, like, you add them, right?
If they're on the same side, yeah, you just combine them. So if they're both positive, you add them. If one's negative, you've got to deal with the negative. Yeah.
But if they're on the opposite,
then you have to get rid of one of them. So you have to subtract one of them. So now we got to get rid of the 13.2 to try to get x by itself. So now we have 0.1x equals 6. And we'll divide by 0.1. So x equals 60. So that's 60. This was milliliters, so that's 60 milliliters. We need 60 milliliters of the 26%. Does that make any sense? The tough part is just getting them set up. I'm going to have you guys try one quick. We're almost out of time, so we'll maybe get cut a little short on this, but let's try it. Let's say you have 41% and, let's see here. 73%. You need let's say you need 64%. How much 73% do you need to mix with 240 milliliters of the 41% to get the 64%? Take a couple minutes, see if you can get that set up. We'll go. Okay, we're running short of time, so let's go through this quick. First thing, of course, is getting it set up correctly. So we have 240, we're combining 41% and 73%, trying to get to 64%. The amount that we have, we know 240 milliliters of the 41%. So that's 0.41 times 240. Plus 73% will be 0.73, and that's the amount we're looking for, so we'll call that x. On the other side, we want 64%, so that's 0.64. The amount will be x plus 240, just adding these two together. 240 plus x, or x plus 240. So now 0.41 times 240 is 98.4. Is that right? Plus 0.73x equals, now over here, 0.64 times x. Is that correct? Did you double check me? No? Double check me. It's good. Okay. So 0.64 times x is 0.64x. 0.64 times 240 is 153.6. Okay, thank you. So now from here, we have to get rid of one of the x's. We're going to get rid of the 0.64x because they're on opposite sides. So that is 0.09x. And we have to subtract the 98.4. So 0.09x equals, oh, what is that, 55.2? And then we'll divide by 0.09. So x equals what? 613.3 milliliters. Not so bad? Okay. Well, in your book, I believe we assigned page 260 yesterday, but just in case you didn't get to it, page 260, that's exercise 6.5, 1 through 25, the odds. And then on page 264, exercise 6.6, also 1 through 25, the odds. We'll talk about the mixture problems a little bit more when we come back from break. And we'll take a day or two to review, and we'll have our unit test.
Just for what we just learned right now?
Yep, this is what we just learned.